This is the most realistic animation of our Milky Way galaxy ever created. At first, it looks exactly as you might expect. Billions of stars arranged in a vast rotating disk. But hiding in our galaxy are some extraordinary features. Look carefully at these colored structures scattered throughout the Milky Way. These are not artistic illustrations. Every single colored point is a real star from real astronomical observations. These structures are called stellar streams. Some are unimaginably long, stretching across tens of thousands of light years. Others are incredibly massive, containing more than 100,000 stars. Many of them are nearly as old as the Milky Way itself, having formed over 10 billion years ago. But streams are much more than just beautiful patterns in the sky. They actually help astronomers address two of the biggest questions of modern astronomy. How did our galaxy form, and how is the mysterious dark matter distributed in our galaxy? We will return to these questions soon, but first thing first, let us appreciate something very important. More than 100 streams have been discovered in our galaxy. How exactly did astronomers identify them? A significant number of streams were only recently discovered using data from the Gaia space mission. Launched by the European Space Agency in 2013, Gaia has been measuring the positions and motions of stars across the Milky Way with unprecedented precision. Using this excellent dataset, astronomers have uncovered numerous galactic structures, including stellar streams. So how did astronomers find all these streams? Basically, they processed the Gaia data using powerful algorithms searching for patterns and groups of stars that are stretched across the sky but also possess very similar motions. But why were astronomers looking for these specific patterns? Well, that's related to the process of how streams actually form. It might come as a surprise, but streams that are so elongated in the sky actually originate from something much, much smaller, a compact cluster of stars orbiting the Milky Way. Each cluster generally comprises more than 100,000 stars. As these systems travel around the galaxy, they get torn apart by the gravitational forces of the galaxy. Over millions and billions of years, this process ends up creating long streams of stars. Even after the stars drift apart from the parent cluster, they retain much of the original dynamics, causing the stars to travel with similar motions. To understand this a little bit better, we are going to do something very interesting. We are going to run a mini experiment, just like how an astronomer would do. For this experiment, we will be focusing on just one stream, the Gaia 1 stream. The experiment is to run a simulation of Gaia 1 and then compare the simulated stream against the real stream data. It is best if we view the simulation in 3 panels. Think of them as different viewing angles of our galaxy. The top 2 panels show the galaxy's Cartesian coordinates, the usual XY and YZ coordinates. The bottom panel shows the Gaia data space. The pink stars represent the present-day observations of the Gaia 1 stream. Now let's rewind the clock by 3 billion years. At this point, Gaia 1 was a compact cluster of stars orbiting the Milky Way. As time passes, the galaxy's gravitational forces begin to tear the cluster apart. Stars escaping ahead of the cluster form the leading arm, shown in red, while stars falling behind form the trailing arm, shown in blue. Watch how this small cluster gradually transforms into a long stream of stars stretching across the galaxy. And finally, when we return to the present day, notice how closely the simulated stream aligns with the observed data shown in pink. This remarkable agreement tells us that the simulation is capturing the history of the stream very well. In other words, our model appears to be a close representation of the reality. Now we are ready to return to our original question. The question that how streams help astronomers understand the formation of the Milky Way, and the dark matter distribution in the Milky Way. Interestingly, this is also connected to the orbits of streams. Notice that the Gaia 1 stream appears as a long arc orbiting the Milky Way. This, in fact, is one of the most interesting and most important properties of streams, that they approximate orbits in the Milky Way's gravitational potential. Astronomers use this very property of streams to understand how our galaxy formed and how is the total matter, including dark matter, distributed in our galaxy, basically constraining the Milky Way's gravitational potential. Consider the Gaia 1 simulation we saw earlier. By detecting and analyzing the Gaia 1 stream, we can understand how this particular population of stars came to be. In other words, we can reconstruct this particular region of the galaxy and understand how it formed. Thus, by analyzing all the different streams occupying different regions of the galaxy, we can understand how different galactic regions formed. Piecing these information together provides us the bigger picture of the Milky Way's formation history. Indeed, streams are the fossil records of our galaxy, preserving clues about events that happened billions of years ago. But there's another important aspect to this story which I did not mention earlier. To run the Gaia 1 simulation, I also adopted model for the Milky Way's mass and its gravitational potential. The model that I chose included three main components: the galactic bulge, the galactic disk, and the galactic halo. While the bulge and the disk are made primarily of stars, the halo consists mostly of dark matter distributed in a roughly spherical shape around the galaxy. Furthermore, I set the total mass of the galaxy to be 10 to the power 12 solar masses. The fact that this Milky Way model is able to reproduce the observed Gaia 1 stream suggests that my chosen Milky Way model and the chosen dark matter distribution in the halo is close to reality. I hope this video gives you a feel of what stellar streams are, why are they so interesting, and how astronomers analyze them. So, the next time you look up at the night sky, remember that hiding within the Milky Way are vast rivers of stars silently flowing through our galaxy.